Yeah, good morning to all. Welcome back to our class. In the last class, we have seen some questions in determinants, and because of some video problem, last class got a bit cut, and I am going to continue that one. Let us see the question. The question is, minus a square ab ac ba ac ba minus b square bc ca cb minus c square equal to 4a square b square c square. 4a square b square c square. Right? This is the question. This question also we have to prove by using the properties of determinants and without expanding. Without expanding, we have to prove this one. Right? Let us see some questions. Let us see the solution. Solution I write here only. This is LHS. We have to take LHS. Right? We can take, observe carefully, we can take A common from first row, B common from second row, C common from third row. A, B, C. You can take A common from first column, B common from second column, C common from third column. That also correct. But here we are going to do both the things, one after the other. First take A, B, C common from first row, second row, third. Otherwise first column, second column, third. In the next step, again you have to take A, B, C common from another part. If you take from rows first, then take A, B, C common from columns. If you take A, B, C common from columns first, then take A, B, C common from rows. Both are compulsory in this question, right? Let us take A, B and C common from R1, R2 and R3. From first row, second row and third row. A, B, C went out. A came out from first row. A went out. So minus A is left. A went out. Okay now. From first row we have taken A common. From second row B went out. A minus B, C. From third row C went out. C I already wrote outside. C went out A. C went out B. C went out minus C. Right? A, B, C. Now again take A common, B common, C common from first, second, third columns. Take A, B and C common from C1, C2 and C3. Okay? From first column A, from second column B, from third column C. First column A went down, so into A, B, C. From first column A went out. From second column B went out. From third column C went out. ABC to ABC, A square, B square, C square. Remind got minus 1, 1, 1. 1 minus 1, 1. 1, 1 minus 1. Okay? Equals to. Now, here the question is, we have to use properties. We should not expand. In the question they mentioned we should not expand. Okay? So let us see how to do. Here, what I am doing, I am going to add, I am going to change like this. I am going to change R2 like R2 plus R1. Right? I am going to change R2 like R2 plus R1. R3 like R3 plus R. R3 I am going to change like R3 plus R. Right? A square, B square, C square. R2 we are changing. R3 we are changing. But R1 is as it is. Keep R1 as it is. R2 we are changing. R2, what are the elements in R2? 1 minus 1, 1. R1 minus 1, 1. Adding, we are adding 1 minus 1, 0. Minus 1 plus 1, 0. 1 plus 1. Right? Next, what we are doing? R3. R3 plus R1. R3. What are the elements in R3? 1, 1 minus 1. R1 minus 1, 1, 1. 0 to 0. Right? We got 0 to 0. Now what I am going to do? I am going to interchange R2 and R3. Sir, first doubt is, why did you do this operation? Second doubt is, how should we come to know to do this operation? A square B, I will explain, just wait. I will explain. A square, B square, C square, keep as it is. Let us see if you interchange these two, what will happen? I am interchanging R2 and R3. Nothing happened to R1. Keep R1 as it is. Second row and the third row we are interchanging. Third row becomes second row. Second row becomes third. There is one trick. While finding determinants, remember very carefully, this is important even for CET also. Why we have taken this one? Why we are interchanging this one? Listen this, then you will understand automatically those. Important for CET also. That is, in determinants, 3 by 3 matrix determinants, if you find 3 zeros, in the shape of L, or in the shape of L, in the shape of 7, in the shape of L means here only. Don't tell that, don't think that. In the shape of L, not applicable. In the shape of L, here only. In the shape of 7, here only. These 3 places, 1, 2, 3. L place, 1, 2, 3. These 3 places, otherwise, these 3 places should be zeros. Either in the shape of L shape, in the shape of L, if you find 3 zeros, otherwise in the shape of 7, if you find 3 zeros, then you no need to expand the determinant, you can multiply the principal diagonal elements. Once again, if you find 3 zeros in the shape of L or in the shape of 7, then you no need to expand the determinant. Directly you can multiply the principal diagonal elements. Okay. What are the principal diagonal elements? Minus 1 into 2 equals to. If you interchange any two rows, negative sign will come. Property. If you interchange any two rows, we get negative sign. Already negative sign is there. This negative sign becomes positive. 2 2s are 4. 4 is a square, is square, is square. So here why I did this one means I am trying to bring 3 zeros in the shape of L. That's why we have done this one. Sir, how should we know? Practice. Sir, I want to do R1 plus R2. You see, you think it. Whether R1 plus R2 gives you 3 zeros or 2 zeros, either in the shape of L or in the shape of 7. Yes, go ahead. No, don't. That you have to do some analysis. Which operation we have to do? Which operation gives us 3 zeros in the shape of L, otherwise in the shape of 7? Once again I am telling, in the shape of L means at this place, at this place, at this place only. If you take that this is L shape, here 0, here 0, here 0, no use. Here 0, here 0, here no use. L shape, here L shape, no. These are 3 use. Okay? So that's why I did this operation. Then I interchanged the second row and third row. I got 3 zeros in L shape. So this is everything okay. We understood. But why to multiply these 3? Same doubt you have. You expand the determinant, you will get the same thing. Really? Yeah, really. You expand it. With which row or which column we have to expand this determinant? With any row or any column we can expand. But which is the simple and easiest one? Either by using first column or by using last row. Why? Because 2 zeros are there. Yes? 2 zeros are there in first column. So we can expand this determinant by using first row. 2 zeros are there in last row. So we can expand this determinant by using last row. That is your wish. Easiest. So I am going to expand by using first column. First row, first column minus 1. What is first column? Minus 1, 0. First column minus 1, 0, 0. Minus 1, where it is? Here it is. Remove these two. 2, 0, 0. Next 0 into something. 0 into something. Why to write 0 into something? Not necessary. One is plus, another one is minus, one is minus, another one is plus. Why 0 it is? Leave it. Minus 1 into 2 2s are 4. Minus 4. 2 into 2, 4. 4 into minus 1, minus 4 we got. So, you no need to expand if you find 3 zeros in the shape of 7 or in the shape of L. Okay? Right? So, here we got out. Understood why we did this operation? This one. Why we interchanged? That's it. Only patience you should have. Patience you should have, with a lot of patience. If you listen slowly, every question you will understand. The problem is which operation we have to take. That you will understand after completion of all questions, then you will get some comment on it. Till that time, you have to listen each and every question. Just listen, understood, yes, go to next question. Listen very carefully. Understand, yes, this operation understood, yes, this operation understood, yes, next operation, yes, next. Okay, why we have done like this? Oh, to get a 0 here, to get 0 here. Okay, next question. By watching many questions, then you will get a command once after reaching some stage. Okay, once if you get command, you can solve the questions on your own. On your own means using the properties which are given in textbook. You have to follow these properties only. You should not invent or discover new properties. Okay. So these are the questions, not over. These are the questions without expanding we have to solve. These are the questions without expanding we have to solve. Let us see the questions with expanding. Next question. Here it is mentioned, by using properties of determinants show that's it, the question is. By using the properties of determinants prove, that is the question, right? In that so many questions are there, let us solve these questions. We can expect 4 marks questions from this. It doesn't mean that last questions will not come. It may come, anyone may come. 1a square, 1b square, 1c square equals to a minus b minus c minus c. That is the question. Okay, right? Okay, this is the question. This we have to prove operations by using properties of determinants. We have to prove. Sir, why we have to use properties unless it is very big headache? Which operation we have to take? That is very difficult. Directly, if we expand, what will happen? Nothing will happen. You get the answer, but don't know on which day you will get the answer. Maybe tomorrow or day after tomorrow. Don't know. That will not sure. If you make some small, not sure means you will get the answer definitely. Why I am not telling not sure means, if you make some small mistake, then you won't get the answer. You cannot find that mistake also. That is very difficult to find. Simplification, small simplification. Somewhere at small simplification, if you make mistake, then it is not possible to get the answer. Right? So that's why let us fill up operations. Right, this is LHS. We have to try to get 2 zeros. Why? Because 3 ones are there. In whichever the question 3 ones are there. In whichever the question 3 ones are there. In whichever the step 3 ones are there. Then we have to try to bring zeros. Why? If you get 2 zeros, then expansion will be easy. Right? So here what I am doing, I am going to change R2 like R2 minus R, R3 minus R. R2, R3 we are changing, R1 as it is. Right? R2. What are the elements in R2? Second one, 1b square, 1b square. R3, 1cc square, 1cc square. Right? Subtraction. Sorry, R2 minus R1, R1 a square. Okay, number a square. Right? R2 minus R1. Subtraction 1 minus 1 0, b minus a, b square minus a square. Right? This 0, this is b minus a. B square minus a square can be written as b plus a into b minus a. B plus a into b minus a. Right? So I am going to write this in place of second row. Second row. Place is not sufficient. I will write like this. So 0, second row, b minus a, b plus a into b minus a. Okay, no? Next, what is the operation? R3 minus R1. Why we are doing like that? To get 0. R3 minus R1. One more 0 will be 2 zeros if you get in any one particular row or in any one particular column. Expansion of the determinant becomes easy. That's right. Right? So R3 minus R. What is R3? What is R3? Third row. What are the elements in third row? 1 6 is square. What is R1? 1a square. 1a square. Subtraction signs get changed. 0 c minus a, c square minus a square. 0 c minus a, c plus a into c minus a. C plus a into c minus a. Right? 0 c minus a, c plus a into c minus a. Okay, now equals to. Next step, anybody? Expansion instead of expanding. No doubt you can expand by because 2 zeros are there. You can expand. But before going to do expansion, there is a chance of taking common. There is a chance of taking common. What is common here? Which is common? Remember, 0 can be written as 0 into anything. 0 into x, 0 into y, 0 into z, 0 into abc, 0 into b minus a, 0 into c minus a. All are correct. So, what I am doing? I am going to take b minus a common from second row and c minus a common from third row. First row as it is, first row as it is. Second row, 0 can be written as 0 into b minus a. 0 can be written as 0 into b minus a. b minus a, b minus a, b minus a common. b minus a went out, 0 will be there. b minus a went out, 1 will be there. b minus a went out, b plus a will be there. C minus a, 0. 0 can be written as 0 into c minus a. So here c minus a, here c minus a, here c minus a. C minus a common. C minus a went out. 0 is there. C minus a went out. 1 will be there. C minus a went out. C plus a is there. Okay? Now if we expand, it will be more easy. Sir, one more thing we can do. If you subtract this one and this one, then we get a 0 here. In the shape of L, we get 3 zeros. Yeah, definitely. You can do that one also. Okay, no problem. But few students may not like the operations. That's why I am going to stop here itself. I am going to expand it. Right? If you got a good comment on doing operation like this, then do it. Which operation you have to do? You have to see R3 minus R. If you want to do, you can do this operation. Zero minus 0, 0, 1 minus 1, 0, 1 minus of b minus a, 1 minus b minus a will come. That's all. Okay? You can do that. No problem. Otherwise, you can expand it. So b minus a. In the proving proving part, actually A minus B is there. A minus B, B minus C, C minus C is there. A minus B, B minus C, C minus C is there. C minus C. A minus B we want, it is B minus C. Take minus common. If you take minus common from B minus A, we get like this, minus of A minus B into C minus A is there. Okay now? Into expand the determinant. Expand the determinant. Which row or which column? First column, by using first column we have to expand determinant. 1 into 1 B plus A 1. Next 0 0, no use of it, right? Even you don't write also no. Keep this minus as it is. Why? Because we want A minus B in the proving part. C minus A keep as it is. Why? Because we want C minus A in the proving part. Expand this determinant. 1 into 1 minus 1 into B plus C. 1 into B plus C. B plus C. Okay. R2 minus R1, B minus C, B square minus A square, C minus A, C square minus A square. Next operation, B minus A common, B plus A, C minus A common. Here C plus A, C plus A, C plus A, right? Here C plus A, C plus A. Here after C minus A common, C plus A, C, right? Then what we get here? C plus A. Then what we get here? C plus A into 1, C plus A minus of 1 into B plus A, B plus A. 1 into C plus A, C plus A minus of 1 into B plus A, B plus A, right? P equals to minus of A plus A minus B, C minus A. Okay now, minus into B, minus B, minus into A, minus A, plus A minus A cancel, minus A minus B, C minus A, C minus A. If you are very good at basics, directly you can write A minus B, B minus C, C minus A. If you are not going to understand that one, how to get, how to write like that, then take minus common from C minus B. In the proving part, we need B minus C, but here it is C minus B. So take minus common, then it becomes B minus C. Minus into minus, it becomes positive. Then A minus B, B minus C, C minus C. Lower class simplification, D is totally lower class simplification, right? So then let us see the next question. Next question, 1 1 1 ABC. 1 1 ABC. A cube B cube C. A cube B cube C cube equals to A minus B, B minus C, C minus A plus B plus C. Right? A plus B plus C. A So here is the question, this is the question. Let us see, this is LHS. So I am going from this one. This is LHS. Right? 3 ones are there in the first row. So 1 minus 1 0, 1 minus 1 0. Right? So where this one is first column, sorry, second column minus first one. Where this one is third column minus first one. So C2 I am changing like C2 minus C. C3 I am changing like C3 minus C. Second column, third column we are changing. First column will be as it is. Second column we are changing. How we are changing? Like C2 minus C. C2. What is C2? Second column. C2 minus C1. C1 is first column. What is first column? 1A8. Right? Subtraction. 1 minus 1 0. B minus A. B cube minus A. B cube minus A. Right? 0. B minus A. B cube minus A cube formula starts with B minus A into B plus A whole square formula. B plus A whole square formula without 2. I already told the trick. Same trick I am explaining. Right? This will come on 6. 0 B minus A. 0 B minus A. B minus A into B square plus BA plus A square. This is second column. Third column. What is third column? How the third column changes? C3 minus C. C3 minus C. C3, third column. 1C C3. 1C C. First column. A 1A 1A. Right? Subtraction. This is in the form of A cube minus B cube, X cube minus Y cube. Okay. C cube minus A cube formula starts with C minus A. X cube minus Y cube formula starts with X minus Y. C cube minus A cube formula starts with C minus A into X minus Y we wrote. Write X plus Y whole square formula. X plus Y whole square formula without 2. C minus A we wrote. Write C plus A whole square formula. C plus A whole square formula without 2. That's it. Right. Third column. So 0 C minus A. 0 C minus A. C minus A into C square plus CA plus A square. Okay, now finally 2 zeros we got. Sir, 2 zeros, okay. See this terrific, my God. I think that is better to expand. What the hell it is? If you start expanding this one, when we get the answer, my God, very lengthy simplification it is, I think, this is better. Next step you see, then you will understand. We can take b minus a common from second column. From second column b minus a, 0 can be written as 0 into b minus a. Okay now, 0 into b minus a, b minus a into b minus a. Take b minus a common. First column as it is. From second column b minus a common. B minus a went out, 0 will be. B minus a went out, 1 will be there. B minus a went out. B square plus ba plus a square. Okay. Next, from third column we can take c minus a common. 0 can be written as 0 into c minus a. Okay. So c minus a, c minus a, c minus a. C minus a went out. C minus a went out to 0. C minus a went out 1. C minus a went out. C square plus ca plus a square. Okay now. Now see, it became a bit simple compared with this one. Right? Equals to. Equals to b minus a, c minus a. Expansion of this determinant by using which row or which column? First row. Why particularly first row? Why? Because 2 zeros are there. So what? Simplification will be easy. That's why we are expanding determinant by using first row. First row expansion. First row, first column. 1 is there. 1 into. Remove first row and first column. What is remaining? 1, 1. 1 b square plus ba plus a square. 1 c square plus ca plus a square. Minus 0 plus 0. Not necessary, right? Equals to. Few stupids are going to cancel minus 0 plus 0. Okay? So b minus a. C minus a. Expand it. 1 into this one. C square plus ca plus a square. Minus. Minus is there, immediately bracket. B square plus ba plus a square into 1. B square plus ba plus a square. Equals to b minus a. In the proving part, a minus b is there. So you can take minus term. Little to now only. Otherwise you can do the last also. No problem. Wherever you want you can do. But finally we have to do compulsory. That I am doing here. Okay. We want a minus b in the proving part. We want a minus b in the proving part. Here b minus a is there. Take minus common. We get a minus b. C minus b add. C square plus ca plus a square minus into b square minus b square minus into ba minus ba minus into a square minus a square. Right? Very important step. Very important step in the complete problem. Up to here you can reach. After that you struggle like anything, but we don't get the answer. In general, every student thinks to take common from this C. C common, C plus A, minus B common, B plus A. Next step is not there. C common, C plus A, minus B common, B plus A. That's it. You have to stop there itself. You cannot move to next step. Remember this step. C square minus D square C A minus B A. Sir, how to remember this step? Very simple. Squares right at one place. Correct. Correct? Thank you. Squares right at one place. Remind at one place. Simple way to remember. Right? So, minus A minus B, C minus A, C square minus B square, A square minus B square formula, C minus B into C plus B. Okay now? A common, C minus B, A common, C minus B. Okay? So here I am going to the place is not there. Here what I am doing for understanding purpose, those who are good at basics, those people can understand in the next step. We can take C minus B common. But those who are a bit weak in basics, those people cannot understand. That's why what I am doing, C minus B alpha, C plus B beta, A only, plus only, C minus B means alpha. Okay? Okay, I will write this first. Minus of A minus B into C minus A. Now, what is that one? Alpha beta plus A alpha. Okay now? Alpha beta plus A alpha, alpha common, beta plus A. Beta plus A. Alpha common, beta plus A. What is alpha? What is alpha? C minus B. Alpha, bracket starts. Beta plus A. What is beta? What is beta? Beta plus. A means A only. A minus of A minus B. C minus A. C minus B is not there in the proving part. B minus A is there. Take minus common, otherwise send this minus here directly you can write B minus C. If I write like that, can you understand? I am sending this minus here, minus into C minus C, minus into minus B plus B. Can you understand? If you are not able to understand, then write the step like this, minus of A minus B, C minus A into take minus common from this. Then it becomes like this, then C plus B plus A. Minus into minus becomes plus. That step also, this also, both of them. Okay? So minus I set here. Remaining this one I am writing in order. A plus B plus C, which is our RHS. Right? Okay, thank you very much. Let us see the next class.